Hello viewers, a warm welcome to my channel. This video is the first episode on my 30-day journey on fractions, where I teach you how to seamlessly interpret fraction word problems into mathematical expressions or equations, and of course solve them. These problems or questions that we will be tackling in this course of 30 days are picked selectively from past state and federal common entrance examination questions, from JSSC, from WAEC, from standard aptitude test, which is SAT. Now, before we delve into the lesson, please be kind and generous enough to click the subscription button below this video to get notified of more productive and academic lessons like this. See you in a bit. So in this lesson, we are going to be tackling just 3 word problem questions. Now let's proceed. Number 1 question says, how many times is 1 and a quarter contained in 12 and a half? Now, to interpret this question, first of all, we are going to put our focus on this how many. Now, when how many is mentioned in mathematics, it can either interpret 2 things, either multiplications or division. But in this situation, since they say how many times is this contained in this, now if something is contained in something else, it means how many of it can it be counted in that bigger one. So this is a smaller number and then this is the bigger number. So I want you to perceive, or I want you to imagine that this number is a basket wherein it is filled with a smaller basket, and then you are asked that how many of the smaller basket is contained in the bigger basket. So to interpret that, we are simply just going to say 12 and a half divided by 1 and a quarter. Now that explains how many of these is contained in this. It's just like saying how many 2 can we count in 6. How many 6 can we count in 36? So how many of these is contained in this? So mathematically, we just simply write 12 and a half divided by 1 and a quarter. Now to proceed with the solution, we convert this mixed number into an improper fractions, which is going to give us 12 times 2, and that is 24. 24 plus 1, and that gives us 25 over 2. Now we've converted this part of the fraction into an improper fraction. Then this divide, we repeat it. Then the next fraction as well is going to be converted into improper fraction. The same way I solve this is the same way I'm going to convert this. So 1 times 4 gives us 4, then 4 plus 1 gives us 5, and that makes it 5 over 4. Now that we've converted this and this into improper fraction, the next step is to do 2 things, and that 2 things is that in mathematics we don't divide fractions in straight plain work like this. First of all, we have to convert this division sign into multiplication signs, and when that happens, something else happens to the numbers in front, the number in front. So what does that mean? It means that we're still going to write our 25 over 2, and then this divide changes to times, and then this divide turning to times, we condition this 5 over 4 to invert. So inverting means the 4, which is the denominator, will come to the top, will become the numerator, and then this 5, which is the numerator, will become the denominator. And from here on, you can look for work and divide. How do you divide a fraction? Now you divide a fraction by checking the numerator and the denominator, which means you can either divide across like this, or you divide like this. You don't divide a numerator by a numerator, neither do you divide a denominator by a denominator. You only divide a numerator by a denominator. So checking this way, we could see that there is a relationship here. That is 5 can go in 25. So 5 in 5 gives us 1, and 5 in 25 gives us 5. Then there is a relationship between these 2 and 4. 2 in 2 gives us 1, and then 2 in 4 gives us 2. And now that is divided, now we check the numerator and see what number we have left. Then we check the denominator and see what we have left. So in the numerator we have 5 and 2 in the left side of the expressions, and then we have 2 in the right side of the expression. So I'm going to proceed by writing 5 times 2, because what is in between them is times. Then all over 1 times 1. 1 times 1. 5 times 2 gives us 10. All over 1 times 1 gives us 1. Now in mathematics, any number divided by 1 gives you the same number. So certainly 10 over 1 is the same thing as 10. That is so. I hope that is understood. So let's move on to the next question. Now let's analyze this sentence and then interpret it. Divide the sum of 3 whole number 1 over 3 and 2 whole number 1 over 2 by their difference. Now we have the first instruction. The first instruction is to divide, but then we're not going to use it because we have an instruction that proceeds and then succeeding this first instruction, the sum of. So the fact that they say the sum of means that we are going to override this divide, and then we proceed on interpreting this part of the problem first. The sum of 3 whole number 1 over 3 and 2 whole number 1 over 2. So sum in mathematics means addition. So we are going to interpret it mathematically as 3 whole number 1 over 3 plus 2 whole number 1 over 2. So divide the sum of 3 whole number 1 over 3 and 2 whole number 1 over 2 by their difference. So we come back to this last instruction later. So now let's first of all solve this. Now, how do you add fractions, especially mixed fractions like this? First of all, we combine the whole numbers together. That is the easier way. There are other ways you can also solve this, but this is an easier way for you. Pair the whole numbers together and then add them because of the plus in the middle. So 3 plus 2, that gives us 5 whole numbers. So I'm going to make a gigantic 5 here and then rule a line for their common denominators. So then we have these fractions left, which is 1 over 3 and then 1 over 2. So we are going to operate on 1 over 3 and 1 over 2 by finding the LCM of 3 and 2. The LCM means lowest common multiple. So the LCM of 3 and 2 is 6. We bring the 6 down below this line as their common denominator. Now that we made the common denominators of these 3 and 2 of these denominators, then we are going to use each denominator to divide the common denominator, then use it to multiply the numerator. I'll repeat that again. We are going to use this denominator here to divide the common denominator. The result we get, we use it to multiply the numerator. So 3 and 6, that gives us 2. And then 2 times this 1 in the numerator, that gives us 2. Then what's in between them is plus. So 2 and 6, that gives us 3. 3 times this one still gives us what? 3. Now we have 5 whole number 2 plus 3 over 6. So we need to simplify this. We are going to repeat this 5, which is still 5, and then 2 plus 3 at the top here, which is still 5, all over this dividing line, all over 6. Now this fraction 5 over 6 is a proper fraction, so we have a complete mixed number, which is 5 whole number 5 over 6. We are not done because the last instruction is there to be implemented. It says divide this, and we've gotten this, which is this, by their difference, meaning that we still need to work the difference. The difference means the subtraction. So we come back to this same number by writing 3 1/3 minus 2 1/2. So the same way we solve this, we are going to solve this. First of all, 3 take away 2, and that gives us 1 whole number. 3 take away 2, that gives us 1 whole number. Then we find the LCM of 3 and 2, which is the same thing as 6. And 3 and 6, that gives us 2. So remember, we multiply the result we get by this one. 3 and 6, that gives us 2. So 2 times 1, we get 2. Then take away. Then 2 and 6, that gives us 3. 3 times 1, we get what? 3. Now, in this situation, you can see by yourself that 2 cannot take away 3. So what do? We borrow from this 1, and anytime you borrow an whole number in a fractional problem, the whole number turns to the denominator. So borrowing 1 from here converts into the denominator, and then the denominator is going to be added to this number to make it bigger and capable to subtract this. So what do I mean by that? We borrowed 1, the 1 will be converted into this denominator, which is 6, and then it will be added to this 2 to make the 2 bigger, and then capable to subtract the 3 and all over 6. Now you can see that the 1 is gone because I've borrowed it, like I said. So now we now have 6 plus 2 take away 3, and that gives us what? 6 plus 2 will give us 8, 8 take away 3, and that will give us what? 5 over 6. So now we've executed this last instruction here, which says the difference. Now we've found the sum, we found the difference. Now let's divide them, because that's the first instruction. So divide this by this. So let's divide this by this. This represent this, and this represent this. So the sum is this, and the difference is this. So let's carry out the first instruction, which says what? Divide. So we are now going to go to the next section of the expressions, which is divide this by this. So I'm going to write 5 whole number 5 over 6 divided by 5 over 6. Now just like the way we solved the question number 1, the same way we are going to work out this. So first of all, we convert this into an improper fractions. How do we convert into an improper fractions? We just simply multiply the whole number by the denominator, which is 5 times 6, and that gives us 30. Then you add the 30 to this 5, so 35. You're going to have 35 over 6, and then we put in the divide, and then we repeat this 5 over 6. Now if you take it in this step-by-step approach, you are not going to miss out any error. That's the essence of taking it bit by bit like this. So then remember what we said, we don't divide a fractions in straightforward pattern like this. We have to do two things, and the two things is that first of all we write 35 over 6, we convert the divide sign into times, and converting this divide sign into times, we condition this 5 over 6 to invert. Inverting means 6 will come to the top, and then 5 will come below. Now how do we then divide? We divide across, like I explained earlier, across. So this 6 can cross out this 6, and then this 5 can cross out this 35. So 5 and 5 gives us 1, 5 and 35 gives us 7, and certainly 6 divides 6 also 1. Now without wasting time, 7 here is the numerator at the top here and the left hand side of the expression, and then 1 up here is the numerator and the right hand side of the expression. What do we do with them? We simply multiply them. So 7 times 1 gives us 7 over, and 1 times 1 gives us 1. Like I said in example 1, any number divided by 1 gives you the same number. So 7 over 1 gives you the same thing as 7. And that is that about question number 2. So let's proceed on to the question number 3. Now let's see question number 3. Question number 3 says, if 26 2 over 5 is divided by 2 whole number 3 over 4, and the result is subtracted from 15, what is the final result? Now let's take it bit by bit. If this is a condition, whenever you see if beginning a question, that's a condition. That means something has to happen before something else happens. So if 26 whole number 2 over 5 is divided by this, that means if this is divided by this. So let's interpret that. 26 whole number 2 over 5 divided by 2 whole number 3 over 4, and the result is subtracted. And the result, now result means whatever we get after dividing this, and we have not gotten the result, which means that we have to solve this and get the results we are talking about. So let's proceed on to solve. Now like we've been doing earlier, so 26 multiplied by 5, and that will give you 130, and then plus 2. 26 multiplied by 5, that will give you 130, then plus 2. So that will give us 132 over this denominator, which is 5. Don't forget how I converted it earlier, this number. Then the divide, repeat, Then 2 times 4 gives us 8. 8 plus 3, and that gives us 11 over 4. Now, what do we do in this situation where a fraction is meant to be divided by a fraction? So we said, we write 132 over 5. Then this divide sign will be converted into times, and then converting the divide into times, we condition this 11 over 4 to invert, meaning that we are going to put number 4 as the numerator, and then 11 becomes the denominator. And let's look for work and divide. Now, looking across this way, 4 can't divide 5. Now, looking across this way, we can guess if 11 can go in 132. So we have to find out. So now, first of all, how do you break down this big number? You pick this 2-digit number, this first 2-digit number, which is 1 and 3, and that makes it 13 because 11 is a 2-digit number. So how many 11 is in 13? That is 1. And the remainder will be 4. 11 in 13 is 1. And the remainder will be 2 rather. So we are going to input this small 2 in between the number, in between 13 and 2. So now we have a new number which is 22. So how many 11 is in 22? And that is 2. So 11 in 132 gives us what? 12. Then we've agreed that 5 cannot be divided by 4. So what do we do with it in this situation where we have no ones? Because the earlier questions we've been solving, we've been getting 1 after dividing the whole fraction. But in this situation, we don't have any 1. So what do we do? Just simply move on by multiplying the numerator by the numerator, and then the denominator by the denominator. So we do 12 times 4, and that gives you 48 all over, and 5 times 11. Pardon me, we've divided 132 by 11, so likewise we should cross out 11 by 11, and that gives us 1. So meaning that here in the left hand side of the denominator we have 1. So 5 times 1, that gives us what? 5. So the only thing we could not divide is 4 and 5. We've divided 11 by 11, that gives us 1. And then we've divided 132 by 11, that gives us what? 12. So now we now have 12 times 4, which is 48, 5 times 1, which is 5. Now how many 5 can go in 48? Because we have to express this into an improper fractions, because we don't leave an improper fraction in its nature. We have to convert. So the same way we solve this, the same way I'm going to solve this. Now, if you know your multiplication table well, how many 5 goes in 48? So 5 in 48 will give us 9 whole number. And then how do you check that? 5 times 9 is 45. So if you take away 45 from 48, you have a remainder of 3. So 9 remainder 3 over 5. So we have a new fraction which is 9 whole number 3 over 5. So this divided by this gives us 9 whole number 3 over 5. Now we've gotten a result. So this is our result dimension here. Now let's proceed on with the question, which says, and the result is subtracted from 15. That is, this result is subtracted from 15. What does that mean? So we are going to draw a new arrows for the new line, So that is 15 subtracted from means that we are taking away this result from 15. We are taking away this result, 9 over 3 over 5, from 15. So that means 15 will precede. So 15 minus 9 whole number 3 over 5. Now, this is a pretty much new subtraction of fractions for this lesson that I'm going to introduce you to. So this is an whole number subtracting a fraction, but it's still easy. What you just do is to follow what I explained in question number 1. Subtract the whole numbers. Since 9 is a whole number, 15 is an whole number. So 15 take away 9, that will give us what? 6 whole number. Then we have a fraction left. So how do we reconcile these fractions, or how do we subtract this fraction from this whole number? What do? We simply borrow 1 from 6, and then we are going to have a new whole number which is 5, and then we are going to write the 1 here and say 1 minus this 3 over 5. I'm going to write 5 as an whole number. Then because we borrowed 1 from 6, The 1 is now here, taking away 3 over 5. Now, in fractions, it is easy for you to convert 1 into a denominator like we explained when we borrowed 1. So you convert the 1 into this denominator by writing 5 over 5. We've converted the 1 into this denominator to make it a common, to give it a common denominator. So 1, take away 3 over 5, the 1 will be converted to 5 over 5 because 5 over 5 will still give you what? 1. So just to give it a common denominator, we decided to pick this 5. It could be any number, but because the denominator we have here is 5, so we decided to convert the 1 into 5. So that they can have a common denominator. So now this 1 has been converted into 5 over 5 because 5 over 5, like I said, is the same thing as 1. Any number that divides itself gives you 1. 2 over 2 gives you 1. 3 over 3 gives you 1. 4 over 4 gives you 1. So meaning that 5 over 5 still gives you this 1. So we are still writing the same thing. Then minus 3 over 5. So 5 over 5 minus 3 over 5. Now there is no need for LCM in this situation, unlike the one I've solved earlier for you. So we just simply subtract it away because they already have a common denominator. So 5 take away 3 and that gives us what? 2. And then over 5 because it's a common denominator. So we come back to this 5 that is written here. So our new solution or our final answer, which is what is the final result? Our final result will then be this 5 whole number 2 over 5, and that is our final result. That is the end of today's lesson. I hope you've learned something. Make sure to kindly click the subscription button below to get notified of more productive and academic videos and lessons like this. See you in the next episode.